including age, education. Question is, should I consider age and education as continuous variable in running regression, or am I required to create it? Okay. May I know the name? May I know the name? May I know the name?
Sir, he's Makund. He's not present actually. Makungu Kalidusi.
Okay, is he present? Is he
I'm just
present
searching.
today?
No, sir.
Okay, still I'm answering to everybody. See, how come the independent variable are all the three: ordinal, binary, and continuous? If it is so, suppose age in ordinal and gender is in binary and income is in continuous, this can be possible. Age is in ordinal, gender is in binary, and income is in continuous, suppose. Then all the three independent variables can be incorporated into regression. So always I am saying it is software or machine which will give you the result. Whatever you give the input, it will give you the result. But whenever I'm taking such classes, I'm saying, I'm giving a warning. The machine or the software has no brain. You need to apply. What does it mean? Is it logically applicable that in a regression, I hope multiple regression, multiple linear regression. If it is non-linear regression, it may be. But it is not clear from the question. Multivariate regression he has written. I suppose it is multiple linear regression. If it is multiple linear regression, one dependent variable and multiple independent variables. Multiple independent variables can be in any scale. Can be in any scale. But is there any logical support behind it? That means whether your literature is supporting behind it. If yes, you can go ahead. But it is always advisable to take in a single scale. To take in a single scale. Why? Reason one is, in the multiple linear regression, the most important assumption is multicollinearity. The most important assumption is multicollinearities. That means there is no multicollinearity. What is the multicollinearity? I have already said this is a assumption in regression, is an assumption. Wherever regression is applied, in SCM also regression is applied. Wherever regression is applied, multicollinearity assumption is most important. The relation between independent and independent is an error for the multiple linear regression, because the researcher is in interest of relationship between dependent and independent. But the equation or the software is giving you the relation magnitude in the form of all dependent and independent, independent and independent. The relation between independent and independent is an error, because the researcher is interested in finding the relationship between dependent and independent. So the researcher is assuming that multicollinearity is very less or negligible or no multicollinearity. So if you are assuming no multicollinearity, relationship between independent and independent are very less, then how can you take different scales? One in ordinal scale, one in binary scale, one in continuous scale. That means by default, you are constraining deliberately, you are constraining the multicollinearity. Multicollinearity is assumed to be nil. You are manipulating the multicollinearity. This means you are manipulating the multicollinearity. Multicollinearity will be lesser if you apply different scale in independent variables. That means you are manipulating. So it is not advisable. Still, if theory exists behind your testing, then you can go ahead. I hope this answers. Suppose you are taking the A's in group, 20 to 25, 26 to 30, 31 to 35, this is in ordinal. And gender, obviously, male, female, it is binary, or 0, 1, it is binary. Suppose you are taking income exactly the same value, that is 10,500, 20,300, 25,625. So these are all continuous. So why not make the age as continuous? Why not make the age as continuous instead of taking as a group? If you make it a group, it become ordinal. If you make exactly 20 year 1 month 2 days, 23 year 1 month 2 day 2 days, likewise. If you can take continuous, then it will be okay. The calculation will be cumbersome, but it will be logically proven it is wise. But however, gender cannot be continuous at any instance. So that is the reason it is not advisable to take different scales as the independent variables. However, if your literature provide the proof that the age, gender, occupation, income are the independent variables behind the dependent variable, that is performance, then you can go ahead. No problem. No problem. So I hope this answers the question. So we should move ahead in the today's session. All of you ready?
Yes, sir. Yes, sir. We will proceed.
Okay, okay, okay. So the person who has asked the question is absent. And this is what the irony. Okay. So again, the same thing
I'm
today.
Present, sir. I'm present. Thank you, Errol.
Okay, okay, okay.
I'm the one
Thank
who
you.
asked that question. Thank you.
Okay, 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 okay. Thank you. Now, could I answer your question? Could I answer,
Okay.
or is it satisfactory, or something else you require?
Yes, yes. Thank you.
Okay.
I have now a knowledge to go through it.
Okay. So let me share my screen for my today's session's PPT. Today we are discussing one of the most important topic in case of structural equation modeling, that is multi-group analysis and invariance testing. In your schedule, it was written multi-group analysis. I am going one step ahead of the multi-group analysis, that is invariance testing. In your workshop schedule, it was written only multi-group analysis, but I'm taking one step ahead of multi-group analysis, that is invariance testing. So today we will discuss something regarding multi-group analysis and invariance testing. So whether my PPT is visible to all? PPT is visible?
Yes, sir.
Yes, sir.
Okay, okay, okay. So today we'll discuss one of the most important topic of our of the multivariate data analysis related to CFA and SEM. Related to CFA and SEM, this is one of the most important topic related to CFA and SEM. This is one of the most important topic, because in order to project, all the academic research are taken by a sample, and projecting towards a population, all academic research or all such our simple research work, we are doing a research by taking the sample and projecting to the population. What does it mean? All the sample elements are heterogeneously behaving, not heterogeneous, homogeneous, not homogeneous in nature, but homogeneously behaving. That means they are true representative of the population. Over the gender, over the age, over the caste, over the religion, over the states of a country, or even if over the countries of a region. Suppose we are projecting the result of sample to the South Asian countries, starting from India, Pakistan, Nepal, Maldives, Bangladesh, Bhutan. Suppose we are projecting the result. We have done some research work in India, and we are projecting the result to the South Asian countries. That means the sample we have taken, we are assuming, not assuming, we are saying that We are saying that the sample we have taken can be projected towards the population. That means second your calculation is, or second step is, that means the sample elements are behaving in such a manner that the behavior can be projected, or the behavior can be taken as similar across the country. Similar across the country. And this thing cannot be assumed. How can you assume that the behavior of sample elements can be taken as similar across the country? If it is in a country, how can you assume that the behavior of the sample elements can be considered as similar or same across the states? If highly heterogeneous mass, suppose for example in India, in food consumption, the food consumption habit of North Indian is mostly different from South Indians. How can you assume it is that the sample behavior, sample elements behavior are similar across the region? So it need to be tested. It cannot be assumed. It need to be tested. If by testing it has been proven that the sample element behavior is considered to be, is found to be similar across the region, across the religion, across the countries, or across the state, based upon your research or hypothesis or objective, then we can say the sample result can be projected towards the population. So this is the basic theme, or this is the basic question upon which the multi-group analysis or invariance testing is going ahead. So very similar discussion we are going, sorry, very simple discussion we are taking ahead. That is, we are saying the behavior of respondents are similar across the gender. That means any measurement we are doing, any simple measurement we are doing, so we will start our discussion from the measurement model. So this is what the latent variable, and these are all the indicators. These are all the indicators. So these are all the indicators. This is the latent variable, and these are all the indicators. And in the AMOS, we are saying it as a reflective in nature. So there is an error. In the AMOS, we are saying it is a reflective in nature. So there are error terms. There are error terms. And this is the latent variable, or we can say construct, or we can say factor. Now the question is, in our sample, both the male and female are there. Both the male and female respondents are there. Very simple question is, very basic question is, can we say that both the male and female respondents are measuring the satisfaction by these 4 indicators same or similarly? Or in a other way, whether these 4 indicators are measuring the latent construct same or similar way over the male and female? Over the male and female? I repeat the question. Whether these 4 indicators are measuring the latent variable F or F1, measuring the latent variable F1 in a same or similar way over the male and female? If it is region, over 3 different regions. If it is countries, over the 7 different countries of SAARC countries. If it is state, over the 30 states of the India. So this question can be examined by the multi-group analysis, or SEM. So rightly, Joreskog, this is the name I was saying. Most of the thing, the Hu, Bentler, and Joreskog and Sorbonne, these 3 authors have developed various things regarding the SEM and CFA. So rightly, Joreskog has said multi-group structural equation modeling test separate structural model. Test separate structural model in 2 or more groups. In my example, these 2 groups are male and female. Can be under marital status, married and unmarried. Can be in the religion, or in the ethnic group, ethnic and the generic. So in my simple discussion, I am taking male and female. So it may be a measurement model or it may be ACM. It may be ACM. Whether the male and female, are taken as similar so far as measuring this particular construct is there. Who is measuring? These four indicators are measuring the construct F1 similarly for the male and female, or in the same way, in the same magnitude for the male and female. If not, if this is not proven, then what is the ultimate? If this is not proven, then what is the ultimate? These four indicators are measuring differently for male and female to the same construct. I am making it simplified. Same indicators measuring the same constructs differently for male, differently for female. This will be resolved if invariance testing fails. Invariance testing fails. That is the reason we are testing. In order to project the sample result to the population, we are testing key the measurement is same or similar to the gender, hence no discrimination can be made, hence the entire sample result can be projected to the population. If not, then there is a problem. If the measurement is happening differently within your sample for male and female, for married and unmarried, then there is a question mark of projecting the sample result to the population. So that is the reason most of the reviewers of the highly reputed journals, they are asking, do the invariance testing. Do the invariance testing for your gender if gender is a crucial variable for your research. Do the invariance testing for marital status if marital status is a crucial variable for your research. Do the invariance testing that your measurement is same both for the male and female. If you win in the test, then we can say invariance testing we win, we can say similarly measuring. If you fail in the test, then you can say invariance testing fails, hence the measurement is done differently for male and female. I hope it is clear, and whatever I have explained, it is written here. So such models may involve path model. I will show you how the path model can be compared. Comparison of indirect effect, confirmatory factor model, full structural model, all these things can be measured, can be tested for invariance testing. So make it more simplified. Multi-group models generally follow the same structure in each group. Same, just I was explaining, same structure in each group, and can provide separate estimates. Same structure, but will provide separate estimates. I will explain how it is giving the separate estimate. If the separate estimates are same or similar, then we can say we win in the invariance testing. That means really measurement is measuring the construct invariably. So separate estimates will be produced. And we will observe, or we will examine by some other testing that the estimates are same or similar or do not differ significantly. How can you say same or similar? They do not differ significantly. Whatever test you do, if you do twice or thrice, some sort of difference will be produced, but that difference must not be significant enough. So by some other analysis, we will say the difference is not significant, hence the similarity can be taken into consideration. So one of the most important way of knowing whether the results or estimates are significantly different or not, we can compare the chi-square result. We can compare the chi-square result to say whether the estimates are significantly differing from each other or not. We will explain that. So what is the multi-group analysis? In the multi-group analysis, as I said, we are going to measure the properties across the groups. Going to measure the property across the groups, which are called as invariance testing. So that is the reason the same measurement properties across the group is considered to be invariant. If the same measurement properties are produced by our testing, same measurement properties are produced by our testing, then we can say measurement is invariant. That means measurement do not differ significantly over the measurement sections, that is male and female. Measurement properties do not differ significantly over the considered groups, if it is invariant. So there are two methods. Mostly we will discuss today the indirect method, because for the direct method some estimates are required. So the time may not permit for the direct method, because it requires some estimates which need to be installed from the start week. It is creating various problems based upon the OS. So let us go. Now look at here. For the male, there is a measurement. The same measurement indicators measuring the same construct. Same measurement indicators measuring the same construct, we are taking it differently for the female. So this exact the figure I have taken from this the exact figure I have taken from this note. This is a very good note on the structural equation modeling. Do not worry, all these things are available freely. That is the reason I have given the source, so that you can refer later on. So all the discussion I have said earlier is following here. We will compare the loading. This is the loading we will compare. That means loading of this indicator on this construct is same than that of female and male. Loading of this particular indicator to this construct is same than that of female and male by comparing it. Likewise, loading of every indicator on the construct are same. This is one way of testing. Second way of testing is taking the intercept. That is the mean value mostly. This intercept here is mean value mostly, based upon what the measurement is improving. Mostly this is mean value. And sometimes even if somebody want to make it more accuracy in testing, they will go for error terms. So mostly these two terms are compared. Mostly these two terms are compared. If more strict examination somebody want to make, then they will go for the error term examination also. Now look at here. So this is one of the famous book. I have directly taken from that book. This is a famous book related to the various type of testing in SCM. From that book I have taken directly these figures. So these figures I will operate in AMOS and I will show you. What you need to do, we need to create the groups first, because the AMOS need to know which group you are testing. I'm sorry, the AMOS need to know, or the AMOS need to be given as an input which two groups you want to test as invariance. So that group you need to create here, that group you need to create here. By this way you need to create. So nothing else. I'm showing you prior to my operation. Do not worry. The exact thing I will show you in the AMOS operation. Now once you create the group, you need to give the input to the AMOS which group consists of which label. Suppose I will say male represent 1, or 1 represent male and 2 represent female. That input need to be given to the AMOS for those two groups. For those two groups separately. So this is the way by which we will give the input to the AMOS. These are all the two groups with the two separate values that we are going to test for the invariance testing. We need to give the input to the AMOS that these are all the two groups with these two separate values or labels that we are going to test for the invariance testing. Then see, I'm quickly finishing all these things so that I will give enough time for the hands-on practices. Today I have mentally ready to, I will give enough time for your hands-on practices. My dear friends, please be ready for your data set. Open your data set and AMOS file. Let us do today enough hands-on practices. Unless and until you do on the very workshop hands-on practices, you will be confused later on. So that is the reason I'm quickly finishing all these theoretical part. I will go to the AMOS operation. Slowly I will do the AMOS operation and you will follow me. Okay. Once you will give different values to the different groups that you will input for the invariance testing, what then you will do? You will make the group values. This is the symbol by where you will make the group values. Once by this symbol you will make the group values for a different path, such like symbols will automatically appear. Such like symbols will automatically appear. Suppose I will say, look at here. Okay, look at here. Suppose I will say 2 for female. So variable 7 for 2. Dekho, look at here. 7 underscore 2, 6 underscore, look at here. 7 underscore 2, 6 underscore 2, 9 underscore 2, 10 underscore 2, 11 underscore 2, suppose. So what these are the meaning ki these 5 indicators are measuring the same construct for the female. If it becomes 7 underscore 1, then these are the same indicators measuring the same construct for male. So these symbols or these weightage or values will be assigned if you click here and move forward in the operation. If you click here and move forward in the operation, such like values will be automatically assigned. Such like values will be automatically assigned underscore 1, underscore 2. Underscore 1 means the same value for the male. The same prefix underscore 2 means measuring the same indicator for the same construct for female. So that AMOS knows you are going to test the invariance testing of the same indicators measuring the same construct over male and female. Over male and female. Now, once you test, now we will know by chi-square. I have already said in the session where I was saying the validity and reliability, C min divided by DF, that we are taking as a chi-square value. So we will compare the chi-square value and I will say you how this is making a difference over the groups. So once you run the invariance testing or group analysis or multi-group analysis, we will compare by looking at this result model comparison. We will compare the result by looking at this result model comparison in order to draw the inference, in order to draw the conclusion whether we win in the invariance testing or we lose. That means whether the indicators are measuring the same construct invariably over the male and female or differently over the male and female. If we fail in our testing, we can say differently male and female. If we win our testing, then we will say, I am using the word win and fail in order to give you a simple explanation at the beginning. But whenever I will go to the chi-square difference comparison, I will use different terms. I am using win and fail in order to make you induce, in order to put you in such simpler term. If we win, then we will say the same indicators are measuring the same construct invariably for the male and female. If we fail, then we'll say the indicators are measuring the constructs differently. Now, and this is what the thing I was saying repeatedly till now. If the p-value is lesser than 0.05, because we are taking everything by 5% level of significance, or we can say 95% level of confidence. So if it is less than 0.05, then not same across the group. That means indicators are measuring the model differently. Please have the concentration. Initially, later on by some other testing method in the macro, I will say it differently. But initially we will go by this thumb rule. Whenever we will go to the macro Excel proposed by Gaskin, there is a different thumb rule. But basic thumb rule is this. If the p-value is less than 0.05, then not same across the group. That means indicators are measuring the model differently across the group. If the p-value is insignificant, that means more than 0.05, then the indicators are invariably measuring the model. Hence, invariance testing is justified. This I have written from my language, do not worry. That means you expect a result initially more than 0.05. You expect a result unless and until your objective or hypothesis is to differentiate. If your objective is to differentiate, then you expect a result less than 0.05. But most of the time we are testing invariance testing. The article reviewer look for invariance testing so that we can conclude the sample result can be confidently projected towards the population. The sample result are not differ. The sample result are not differing over the country, over the state. So putting a question mark whether the sample result can be projected towards the larger population or not. There will be a great question mark if it will be proven that the sample result are testing or measuring differently. Then there is a great question mark. That means your sample result cannot be projected to all the states, all the religion, all the countries of a particular study area. So the reviewer of the article, they expect the invariance testing you should win. That means they expect that the invariance properties are available. That means the p-value should be more than 0.05 in order to say that the indicators are measuring the construct invariably or similarly or in a same magnitude or do not differ significantly. The indicators do not differ, the indicators measuring the construct do not differ significantly over the male and female. So this is what the thing we need to prove. In order to prove this, we expect a result p-value should be more than 0.05. I repeat, we need to test, we need to prove that the indicators are measuring the construct, same indicator are measuring the same construct invariably or not differently, not significantly different over the male and female. We are testing this. In order to test this, we will prove or we expect a p-value result more than 0.05. I hope it is clear. All these things I explained by taking a measurement model. Now, if it is a path model or structural model, path by path, so this has been measured by 3-4 indicators. Another thing has been measured by 3-4 indicators. Another has been 3-4 indicators. Another, the same example I was repeating since last 4-5 sessions. Suppose it is attitude, suppose it is satisfaction, suppose it is performance. This has been measured by 3, this has been measured by 6, and this has been measured by 4 indicators. So now this is the path. Attitude leads to satisfaction, satisfaction leads to performance, and plus attitude leads to performance. Suppose this is the model that you want to test. So these are the path. If you are taking the path as a invariance testing, we have already completed this measurement model till now. If you are taking the path as measurement testing, then in the same way, but the interpretation will be different. The path effect of exogenous variable on the endogenous variable is differing across the group if it is less than 0.05. For this, it is exogenous, it is endogenous. For this, it is exogenous, it is endogenous. For this, both the things are exogenous. So these are the things we have already discussed in the initial 1-2 session. So that is the reason we are saying the exogenous variables having the influence on endogenous variable on the same magnitude over the male and female. Or we can say the effect of exogenous variables on the endogenous variable do not differ significantly. Do not differ significantly over the male and female. So this is the thing we want to test. So now the same thing, this is what the structural model, path model, this is what the thing I am repeating over the time period because our basic is this and assumptions are must. SCM assumptions are must. That is the reason I am showing it repeatedly. Bas, that's all. That's all. That's all. Now we will go to direct AMOS operation. My sincere appeal to all of you my sincere appeal to all of you, please be ready with your AMOS graphics and SPSS datasheet that I have sent yesterday. I hope the organizer has sent you all the same datasheet. Only in the male and female, I have made some modification which is suitable for this testing, because some missing values were there. So that is the reason same data set I have sent yesterday to the organizer. They might have sent you the same data set, but the male and female, but the gender and marital status, I have modified something which will be suitable for our analysis today. I hope all of you are clear till now. If any theoretical or conceptual clarification required, you can ask. Then I will go for operations, AMOS operation. Open to all of you, please. If you require any conceptual or theoretical clarification, just quickly make it clarified. Then I will go for AMOS operation. Dear participants, anything?
Yes, thank you, sir.
Anything till now?
It's clear, sir. Thank you.
Ravindranath Hota, are you there?
Yes.
Are you there? Are you
Yes,
following?
I am present.
Are you following?
Sir, in fact, frankly speaking, I have dealt with this SPSS for last 15 years. And mostly I do the numerical data. And so, sir, I am sorry to say that the fundamentals or the theory behind this SPSS and AMOS, etc., these have very little meaning for me. In fact, I was expecting that whether the organizers will say something regarding SPSS, how to practice and how to deal with, and what are the simple mistakes normally we do. So that I was expecting. But what I saw in these last several days is that mostly we are using SPSS for social science, in which the data are completely different from the data which I used to use for SPSS.
See, sir, some beginners are there. For them, some basic theoretical or conceptual clarity is required. And
yes,
moreover,
certainly, yes, sir, because this is the SPSS, that is the statistical package for social science. I cannot expect that it to be 100% mathematically oriented. That I agree. And you are also, sir, 100% true, because the fundamentals are also necessary.
okay. So right from now, we will go for AMOS operation. See, most of the time, Ravindranath sir, most of the time, what we need to know the logic, because whatever data we will give to the AMOS or SPSS, any data you will give, they will provide some result. But most of the time, what the scholars or what the researchers, they forget how the data will be interpreted looking at the objective and hypothesis. So that is the most important thing. So that is the reason background conceptual clarity is required.
Okay. Sir, I have a small question, please. Sir, I have till now, I have used only SPSS and Statistica. Normally, I had the very, say, rudimentary models, that is SPSS 6, 7, Statistica 6, etc. I did my work there. So now, I am very new to this AMOS. Whether using AMOS, I can calculate the correlation coefficients, the factor analysis, the multivariate regression. Sir, are they possible in here also?
Sir, you are present in my initial 4 sessions.
Yes. And
so
I
have repeatedly said,
yes,
structural equation modeling is nothing but mostly a combination of factor analysis and multiple linear regression. So definitely, the basis of structural equation modeling that you do in AMOS, based upon coefficient of correlation, regression, covariation.
Yes, sir.
Are you getting my point?
Yes,
so
sir. Yes,
whatever terminology you use, that are very basic to the AMOS operation.
Achha.
Because tell me.
Sir, I am very new to this AMOS. So, and frankly speaking, whatever you taught, of course, you taught from the very fundamentals. That also I know, etc. But sir, can I use these things in the same way I used in SPSS? Because I have, sir, frankly speaking, I have hardly that understood
sir,
this
I
AMOS
think
operation to
okay,
the
okay,
next
sir, okay,
extent.
sir. I think you have ignored most of the part of the initial 2-3 session. I have said you need to have sufficient theory or existing literature to test a model. AMOS is meant for testing a model, or ACM is testing a model having sufficient background theory and conceptual clarity. Okay, so the time is very short. You need to go for that. Okay, I think nobody else have any conceptual clarity requirement till now. We will go for the AMOS operation. All of you are ready? All of you are ready for this?
Ready, sir.
Yes,
Okay.
sir. Yes, sir.
So, okay, this is what the model, another model I am taking. So that is a problem in sharing the file immediately. That is the problem. That is a problem of sharing the file immediately. Otherwise, I could have shared this file also. Anyway, so the same file
Yes,
I'm
sir.
using.
Yes, sir.
The same file I'm using. Okay. This is the file. This is the same model you have prepared in your previous sessions. Is that right? This is the same
Yes,
model.
sir.
Okay. So what we need to do, what we want to do now, we want to measure or we want to prove whether the same type indicators, are measuring the F1 similarly over the male and female, and the same question for the F2, F3, F4, F5. Whether the same type indicators, that is BSI 6 to BSI 10, are measuring in the same way F2 over the male and female, and the same is the question for rest of the three constructs having their underlying variables or indicators. In order to test this, we need to make a multi-group analysis first, then I will go for invariance testing. All of you please look at here. In the left hand side, something is written group number 1. All of you look at here. If see, slow and steadily I am doing. If anybody is facing problem, immediately raise the question. I request the organizer to give the pass or give the access to anybody if asking the question. Immediately write the question or say difficult in the chat box so that the organizer will enable you. Okay. So all of you please look at the left hand side. There is a icon written as group number 1. All of you got this? If anybody is facing problem, all of you got this? Yes or
Yes,
no?
sir.
Anybody say yes
got
or
it,
no?
sir.
Okay.
Group number 1.
There. Okay, double click there. Double click on the group number 1. Double click on group
Yes,
number
sir.
1. Such like a
Done,
pop-up
sir.
box will appear.
Yes,
See,
sir.
delete the group number 1. Delete that particular term and write male. Delete that group number 1, that particular term.
Means we have to overwrite as male.
No, delete that first. I am saying slowly. Please follow me one by one. Very slowly I am saying. Delete that 2-word group number 1. Then write male. Then click on new. Then again, another term is coming, group number 2. Delete that and write female. All of you please write female. Now, group naming operation is over. Nothing to do now. Close it. Simply close it. We have given the input to the AMOS. There are 2 groups. Simply close it. So 2 groups has been created. One is male and another one is female. 2 groups has been created. AMOS is given with the input of 2 groups, male and female. All of you made it till now. Should I proceed? Please say anybody yes or no.
Yes, sir.
Okay. Now, the next step is giving the data input to the AMOS. Giving the data input to the AMOS. The operation is same. Go to this icon. Please look at my cursor movement. Go to this icon. It is showing select data file. The same. Select data file. Select data file. Then locate your data file. Click on file name. Click on file name. Then locate your data file. The data file I have sent yesterday. Locate your data file.
Yes, sir.
Locate your data file. Okay, let me go to my data file. Let me go to my data file. Locate your data file. Click there, then open. Click there, then open. What you need to do, then you need to go for the icon group variable. Remain in the same pop-up box. Do not leave the same pop-up box. Remain in the same pop-up box. That is the icon group variable. All of you got? All of you got?
Yes, sir.
Then click there, group variable. Click there, group variable. Go to the name gender. I'm going, look at here, I'm going. Go to the name gender. Click there. Click OK. That means I have given input to the AMOS that based upon gender, I want to test the multi-group testing. Now, what are the label? There is another icon group value. In the same pop-up box, there is another icon group value. Click there. Click there. Then such like another pop-up box will automatically appear. Look at my screen. Such like another pop-up box will automatically appear. Click on 1 because I have given male as 1. Click on 1, then OK. Now AMOS is successfully given with the input that 1 means male, and we are testing the multi-group testing. We are doing the multi-group testing based upon gender. All this information have been given to the AMOS. That means here you can easily locate. Please, you can easily see that male are 291 out of 556. My sample size is 556. Out of that, AMOS has given me the initial information that 291 is the male. The same operation you repeat for the female. Just double click on female. Just double click on female. It will propel you. It will prompt you to the data source directly. It will prompt you to the data source directly. Click on the data source or data file, then open. The same. See, another important thing I'm saying, you can keep 2 data file also here. If it's the same, then the same data set. So the same operation, go to the grouping variable, go to the gender, click OK, then go to the group variable, then click 2, it will be highlighted, 2 will be highlighted, then click OK. Now look at here, 265 female. AMOS has given me the information. Up to this, all of you have done. If anybody is facing problem, please frankly ask. Please frankly ask, because this is the initial operation. If anybody is failing here, then the subsequent operation will not be understandable at all. It will be very difficult. Up to this, everybody is clear? Up to this, everybody is clear? Up to this, everybody is clear?
Yes, sir.
Anybody say yes or no?
Yes, sir. Yes, sir.
Yes, sir.
Okay,
Yes, sir.
then
Yes.
click OK. Then click OK. Click OK. Now, AMOS got every information. AMOS got every information based upon which I want to test. Based upon which I want to test. Let us go to the output that I require. Go to the output that I require. Please click here. Already I have made the operation. So it has been checked. It has been ticked. This minimization history, standardized estimate, square multiple correlation. The things you require for your hypothesis testing, you need to tick there, then close. Then let us start operation or start calculating. Calculate the estimates. Let us see what is happening. Let us see what is happening. Now look at here. Look at here. The upward red highlighted arrow mark I am clicking. And let me go to the standardized estimate. Standardized estimate. All of you please look at here. The F1 to F5 covariance is 0.49. For whom? For male. For male. And let us go to the female. Now look at here 0.57. For male, it is 0.49. If you go to the female, it is 0.57. That means covariance between F1 to F5 is higher than the male for the female. Than the male for the female. For the female, it is, look at here, the figure that has been red highlighted. It is 0.57 for the female. The same thing for the male, it is 0.49. 0.49. The same way we will go to this factor loading. Look at here. The same way we will go to the factor loading. Look at here. BSI 5 is loaded on F1. That means BSI 5 is measuring F1 by 0.75 for the male. Look at here. Look at the female. BSI 5 is measuring F1 by 0.74, little bit lesser. The same is the case we will go. BSI 4 is measuring F1 by 0.78. Look at here, by 0.78. By points, look at the red highlighted arrow and the assigned indicator, 0.78. Now the same thing, how much is for the female? For the female also 0.78. For the female also 0.78. Now going to the BSI 3, for the male, it is 0.60. No, sorry, 0.77. Look at here. Look at here, the red highlighted arrow and the assigned digit, that is 0.77. So BSI 3 is measuring the F1 by 0.77, and for the female, it is measuring by 0.72. It is measuring by 0.72. So the initial indication we got, some difference are arising. Some difference are arising. The same question please remain in your mind, whether this difference is significant or not. Please put this in your mind. Later on we will solve this problem. But initially we got some differences there. The same indicator measuring the same construct little bit differently to the same construct over the male and female. But the question is it significantly differing? If not significantly differing, then we win in the test, that is invariance. That we require, or that the reviewer require, invariance. See, whatever data you will give, whatever group you will create, some difference will be there. But in the statistics, we need to say the difference is significant or not. So initially we got little bit difference is there. Later on we will find whether it is significant or not. Any difference? For the sake of example, I have taken one by one factor loading, but later on I will say the other part, that is the chi-square difference of any covariance, or factor loading difference based upon chi-square, or path loading or path regression magnitude by chi-square. So many other things are there. I will go later on. But initially I wanted to tell you that some difference is there. This is the basic meaning of group analysis or multi-group analysis in the SEA or CFA. In the CFA or SCM, multi-group analysis basic purpose or basic meaning is this. Now, what is the most important part? Most important part is model is fitting or not. This may happen. Model is perfectly fitting to the male, may not fit it to the female. This may happen. If model is fitting to the both male and female, then subsequent analysis of invariance testing will go for. If model is not fitting, then invariance testing has no meaning at all. from the very meaning it is clear, there is a significant difference. I repeat, if model is fitting for male, model is not fitting for female, then from very beginning it is clear that the measurement or the structural equations are significantly different from each other over the groups that we have defined. If they are not defined, if the model is fitting similarly or fitting absolutely both for the male and female, then subsequent test is required. So let us go to the model fitting. So let us go to the model fitting. Click on the text output, view text. There is a icon view text. Look at my cursor movement. There is an icon view text. Click there, view text. Click there, view text. So that is also available in the view menu. This is also available in the view menu. I have repeatedly said. So directly we will go to the model fitting indices. There is a option in the left hand side. Look, model fit. Click there. Model fit. Click there. It is not showing. So model is fitting. Look at here. GFI is more than 0.9, and almost all NFI, RFI, IFI, TLI, and CFI, these are all showing more than 0.9, except one, that is 0.89 or 0.88, but this will be improved by modification indices. In my fourth session, I have said the modification indices. If you do the modification indices, happily it will increase from 0.88, from 0.89 to 0.91, 0.90. So RMR will be very okay if it is less than 0.05, but if it is less than 0.08 also, it can be accepted. So here it is less than 0.08. Look at here. Now coming to the RMSCA, it is very much acceptable because it is less than 0.05. The value is 0.034. So RMR, RMSCA are less than 0.08 or 0.05. So acceptable, model is fitting. GFI, SGFI, NFI, RFI, IFI, TLI, and CFI, these are all over the acceptable range. So model is fitting. So initial question is clear. There is no hesitation regarding model fitting. There is no hesitation regarding model fitting. And the C mean divided by DF, this is chi square. The C mean divided by DF, this is nothing but chi square. And this should be less than 3. I have already said, repeatedly I have said in my session 3rd and 4th. So it is 1.623. So it is less than 3. Again, another indication, another fit indices is saying model is fitting happily. So chi square is less than 3. So model is fitting. Apart from all other fit indices, just I have explained, I got the C mean divided by degree of freedom is less than 3. So again, it is substantiated that model is fitting. Model is fitting. I hope all of you are clear. Now coming to the estimations. Now look at the estimations. Automatically the male and female has been activated. Automatically the male and female has been activated. Look at here. All the P values are 0.000. See, triple star means 0.000. That means less than 0.001. Less than 0.001. That means all the relationships are significant even on 1% level of significance. Mostly we are taking 5% and the strict principle is 1%. All the relationship of my model are significant even in the 1% level of significance for the male. For the male, look at here, these are for the male. Let us test another thing, whether the same result we are obtaining for the female or not. Go click on female, and the same result. See, these values are differing. The estimate, CR, SC, these values are differing, but the P values are same. That means these are all significant at 1% level of significance. That means initially I got the conclusion that, or inference, I cannot say conclusion, inference, initial inference we can draw that there is no such significant difference. Although there is some difference, look at here, I clicked in the female, look at the value, CR value 13.969. What is that? BSI 2 is loaded upon F1 by the CR is nothing but the T value, not loaded, significant by the value 13.969. Click on female. Now it becomes 12.513. It is for male, and for the female 13.969. Values are slightly differing, but the most important significance P value are not differing. That means initial inference I have drawn that the measurement variables or measurement indicators are invariably measuring the constructs. That means the measurement indicators are not significantly differing to measure the construct over the male and female. Initial inference we have drawn. This is the initial inference, but not the conclusion. If you say multi-group analysis, here is your multi-group analysis, nothing more than that. यहाँ पे multi-group analysis is over. But this much is not required for the reviewer of the article. A reviewer of the article, they require invariance testing. That means you need to prove there is no significant difference between male and female. No significant difference means the invariance testing is win or justified. That means invariably or similarly the indicators are measuring the construct. The reviewers or the thesis examiner are looking for invariance testing, not this basic multi-group analysis only. So we will take one step ahead of multi-group analysis. We will take one step ahead of multi-group analysis, that is invariance testing. Till now, any doubt? Till now, any doubt? Should I proceed? Till now, any doubt?
No doubt, sir. No doubt, sir.
Are you all following?
Yes,
are you all
sir.
following? Bapan sir following?
Yes, yes, sir. Yes, sir. Following, sir.
Okay. Apurba Saha, are you here? Apurba Singh and Apurba Saha, are you there?
Yes, sir. Yes, sir.
Hi.
Yes, sir. I'm here.
Are you following? Are you following?
Apurva Singh.
Are you following?
Yes, sir. Yes, sir. We are listening.
Are you practicing?
Yes, sir. I'm listening. Yes,
Okay,
yes,
no,
sir.
are you practicing
Yes,
or
sir.
not? Okay, okay. Very good. Anjali madam, are you following? Listen.
Yes, sir.
Okay. Are you practicing the same thing?
Yes, sir. Yes, sir.
Any doubt till now?
No, sir. No, sir.
Okay. Nina George, are you following? Nina George, are you following?
Sir. Yes, sir.
Are you
Yes,
practicing in the? Are you practicing in the AMOS?
Sir.
Okay. Are you practicing in the AMOS?
Yes, sir. Yes, sir. Yes, sir.
Any doubt?
No, sir.
Okay, thank you. Manisha Khanna, are you following me? Okay. So I hope the last session people are getting bored. I do not know. Okay. Bapan sir, could you do all these things? Could you do all these things? Bapan sir, could you do all these things? Bapan. I hope. Anyway, Suman De, could you do all these things? Suman De, could you do all these things?
Yes,
are you
sir.
Listening?
Yes, sir.
Have you practiced all these things?
Yes, sir. I'm doing it.
Okay. So let us move ahead for the invariance testing. Let us move ahead for the invariance testing. Look at here. Till now we have given the input to the AMOS that the male and female, and the label are 1 for male, 2 for female. Now we will make the group. We will give the AMOS to a group. On which basis AMOS will give us the result? Look at here, there is a icon. It is written multi-group analysis. There are four heads. There are four. Look at my cursor movement. There is an icon. If you slowly put your cursor there, it is written multi-group analysis. Click there. Click there, and such like pop-up box will appear. Do not worry for this. Click OK. Click OK, and such like pop-up box will automatically appear. Such like pop-up box will automatically appear. Look at here. Is it appearing? Is it appearing, Bapan? Is it appearing?
Yes, sir. Yes, sir. Yes.
So nothing to do. Whatever tick mark has already been selected by default, that is okay for our initial analysis. So click OK. Simply click OK. Now look at here. Look at here. Automatically it has been assigned with some constraints. What these are? These are some constraints. Automatically assigned some constraints. Look at here. It is written CCC 4_1 for the male. Look, go to the female 4_2. Some constraints has been assigned. Now look at this. For the female, it is written A_2. For the male, it is written A4_1. So AMOS could know that there are two different constraints for male and female. AMOS could know there are two different constraints for male and female. All of you clear till now? All of you clear till now?
Sir, would you please repeat, sir? Repeat the process, sir.
Simple. Go to this icon. I'm moving around my cursor. Go to the icon.
Okay. Yes,
put
sir.
your cursor slowly. Look at here. It is written multi-group analysis. Click there.
Yes, sir. Yes, sir.
Click there. Once you click, there will be another pop-up box. Something is written. Do not worry. Click OK. Automatically another pop-up box will appear. Automatically another pop-up box will appear like this. Like this. Some options has already been ticked by default. No need to do anything.
Yes, sir.
No need to do anything. Initially, this much of tick mark is okay for our initial clarification. So nothing to do. Click OK. Once you click OK, automatically these constraints will appear for you the same way but differently for male and female. Like, look at here, it is written CCC 4_1. 4_1 means fourth covariance for the male. If you go to the left hand side and click on female, see what it is written 4_2. What it is written 4_2. All of you clear? 4_2.
Yes, sir.
Is it clear till that? Till now?
Yes, sir.
Okay. Okay. So now this much we have done, and we have given the information to the AMOS. These are all the constraints based upon which we will measure. Now repeatedly I am using a word constraint. Repeatedly I am using a word constraint. That means giving a constraint we are comparing with unconstrained value. I repeat, giving a constraint, जबरदस्ती एक constraint डाल देंगे. We will compare with the unconstrained value. If the constraint values are significantly different from unconstrained value, then we will say कि the male is significantly different from female so far as measurement is concerned, so far as path is concerned, whatever you are testing based upon your objective. If you are testing based upon your objective only the measurement, then measurement. If you are going for structural equation modeling, then it is path. Or if in the full structural model, both for the measurement and path. So what we need to test, I'm repeating again, we will compare the constraint values with the unconstrained values. Look at the left hand side box. I am moving my cursor. There is something written unconstrained, and there are something written measurement weight, structural covariance, measurement residual likewise. Measurement residual likewise. All of you are clear? All of you are clear till now? All of you are clear till now?
Yes, sir. Yes, sir. Yes.
So whatever we have tested, this is named as configural invariance. This is configural invariance. Configural invariance, whatever we done prior to this step, whatever we have done, the fit indices are fitting both properly, the measurement weight are not that much of difference, the significance of p-value are same for both. So initial inference we have drawn, no, there is no such significant difference. So we win in the invariance testing. So this is very basic measurement. So that is what named as configural invariance. In the multi-group analysis, we are naming it as configural invariance. Configural invariance. We have gone up to this step of making constraint. किसी चीज को constraint करेंगे, then we will compare with the unconstrained values. Then this type of test, if you are making constraint for the factor loading, यानी कि factor structure, factor loading we are constraining. So we will say we will constrain the factor structure and we will test by comparing the unconstrained value with the constant value, which is called as metric invariance. From this step onwards, whatever I am going to do, this is what called as metric invariance. METRIC, metric invariance. Prior to this step, whatever I have done, that is what called as configural invariance. From this step onwards, whatever I am going to do, this is what called as metric invariance. Metric invariance. Likewise, so many other constants are there. Suppose you are making constraint for we are making constant for both the factor structure and residual, or both the factor structure and path. So many other constants are there, but this is what the reviewer or article or examiner of thesis mostly require. Ki make the factor loading or weightage constraint, that is factor structure ko constraint karo and compare. Then what if it is significantly differ, then invariance is not there. If it is not significantly differing, then invariance is there. So what we will do, we will do the operation now. Start operation. Start the operation now. Now look at here, 0.57 for female, 0.549 for male. But this is not the most important. We are going to the text output. We are going to the text output. I hope my photo is creating problem. So let me switch off that so that my voice will be clearly audible to you. Okay. Look, go to the text output. Go to the text output. Go to the text output. Now look at here. Automatically this has been available to you. Ki on constant value, measurement weight, structural covariance.
Not visible.
Yes.
Screen is not visible, sir.
Not visible.
Visible, sir.
It's fine. It's fine now,
Visible, sir.
Okay. So look at the left hand side. Some options are automatically available for us. Look at my cursor movement. I am moving. Unconstrained, measurement weight, structural covariance, measurement residuals. So many things are there, but we initially require measurement weight. These are all factor loading. These are all factor loading of the factor structure. These are all factor loading of the factor structure. Look at here. Now we will go to the pairwise parameter comparison. Look at here. First, let us go to the estimates. The same thing. The estimate same thing for the both male and female. Let me confirm. Yes, same thing. Now coming to the pairwise parameter comparison. Pairwise parameter comparison. Okay, this operation I will go later on. Go to the model fitting. Go to the model fitting. Look at here. Look at here. Unconstrained is also unconstrained and constrained both are also less than 0.03. So look at here. Unconstrained is the number one. Look at here. Look at here. Unconstrained is less than 0.03. and all the constraint values are also less than, less than 3, not 0.03. I'm
3.
sorry.
Yeah, 3, sir. 3.
Less than 3. That means
Yes, sir.
both the constrained and unconstrained are less than 3. That means they are not significantly differing from each other. They are not significantly differing from each other. Yani ki we win in the invariance testing. This is the second phase by which we prove there is a invariance. Now coming to the coming to the fit indices, again more or less the same values. More or less the same values. What is the same value? Same value of constrained model in comparison to the unconstrained model. I repeat, same value for the constrained model in comparison to the unconstrained model. In comparison to the unconstrained model. So nearer, more or less same values. Look at here: NFI, RFI, IFI, TLI, and CFI. All these are more than 0.9. Even in some cases it is 0.95. After constraining also. So this is the second phase we over. Now click on model comparison. Click on model comparison. Look at here. There is a left hand side option called as model comparison. Click there. There is a model comparison. Click there. Now look at here. Click there. There is a model comparison. Click there. Now the most important inference we can draw from here. The most important inference we can draw from here. Look at here. Assuming unconstrained to be correct. That means जबरदस्ती we constraint हमने constraint कर दिया, but we assume unconstrained is correct. It is written assuming unconstrained to be correct.
Excuse me, sir.
Yes.
Model comparison is not shown here, sir.
How come? Anybody else is facing same problem? Anybody else is facing same problem?
Yes, sir.
Model-
Yes, I'm facing same.
Same problem.
Yes, sir.
Okay, Bapan sir, can you please view? Make me view. Make
Okay,
the,
okay, sir. I can. Yes.
Please, organizer, please allow him. I am stopping the sharing. Please share your screen. Bapan sir, please share your screen.
Yes, sir. I'm doing, sir.
I have stopped my share screen. Please share your screen.
But sir, still it is not allowed, sir.
Anybody from the organizer, please allow. This is what the problem.
Now
Anybody
it's allowed. Now is allowed. Go ahead.
Bapan sir, please share your screen.
Yeah, I think. Just a minute, sir.
Please share your screen.
Is this visible, sir?
No, your name is coming, but your screen is not visible. Share your model. Now it is visible.
Yes, sir.
Model comparison is not coming. See, Bapan
Yes,
sir,
sir,
you have not done the operation. Go to your model. You have not done the operation of the multi-group because it is not appearing in the below. You have said yes, but you have not done. Go
yes,
to the
done,
model.
Sir.
No, you have not done. Go to the model. Go to the model, please. Or go to the model,
Sir,
AMOS model.
Yes, sir. I am in the AMOS model, sir.
No, it is not visible to me. Go to the AMOS model.
Just a minute, sir.
Stop.
Then I have to stop
Please,
yeah.
Please close the output screen. Please close the output screen. Go to the AMOS model, share again. Go to the AMOS model, share again. Go to the AMOS model.
Yes,
Click,
sir. Is this?
Click on the group invariance. Click left. There are 4 head, human being head. There are 4 left. Icon. Go to the icon, sir. No. Below. Go to then below. Yes. Click there. Okay.
Okay.
1 minute. Please hold on. Please
Yes,
hold
sir.
on. Hold on. Hold on. Is it appearing to you?
Yes, sir.
But to me, it is not shown. So click there. Click OK.
Yes, sir. Yes, sir. Done, sir.
Then go to the output icon.
You.
No. Output. You have not done the operation, sir. You have not done the operation. Go to the output.
Yes,
What
sir.
output
Yes, sir.
you require? These three windows. Go to the.
Okay. Yes. Yes.
Yes. It is okay. Yes, it is okay. Okay. Close that.
Yes, sir.
Close that.
Yes, sir.
Go to the data file. Go to the data file. No. Here.
Yes.
Go to the
Yes,
data
sir.
file. Yes. Click there.
File name.
Yes. You are okay. You are okay. Arey yaar, you are okay. Do not be hurry. Bapan sir, you are always in hurry. Close that.
Yes, sir.
Close that. Okay. Click OK. Now estimate.
Calculate.
Yes. Calculate estimate. Yes. Yes. Now go to the text output. Do not be hurry. Go slowly. We are hurry and you are clicking here and there. Text output is appearing to you.
Yes, sir.
But it is not appearing to me. Text output is appearing to you.
Yes, sir.
But not shown to me. It is not appearing to me.
I think, sir, now it will show. Is it showing, sir?
No. Close this. Minimize this, and go to the text output. Minimize the AMOS graphic and go to the text output. Minimize, sir. Minimize the text output and goes to the AMOS output. Minimize this. Yes. Minimize and open the text output.
Yes, sir. I got it. Model comparison, sir. Now.
You got it now?
Yes, sir.
Okay. So stop sharing.
Okay.
So any madam was saying unable to do. Madam.
Yes, sir. I got it, sir.
You got it now?
Yes, sir.
Okay. Let me share my screen. My screen is visible to all.
Yes,
visible
sir.
to all.
Yes, sir. Visible.
Okay. Now look at here. What is our thumb rule? Look at my PPT. What is our thumb rule? Thumb rule is it should be more than 0.05. To win, please mute yourself. Anybody's voice is disturbing. Please mute. Okay. Please mute. Anybody's voice is disturbing. Please mute. Okay. So our thumb rule is what we expect. We expect more than 0.05. In order to say that the invariance is proved, we require more than 0.05. Now look at here. All the values are more than 0.05. Look at here. This value, and this value. These are all more than 0.05. Assuming that unconstrained is correct, we are comparing the constraint with the unconstrained, and the p-value is insignificant. That means models are not different from each other so far as male and female is concerned, or over male and female. What I'm saying, model testing is insignificant because the p-value is more than 0.05. Insignificant means the model measurement or the model is not testing significantly differing. The model is not measuring significantly differing or significantly different over male and female. That means invariance is proved. Invariance is proved. That means invariance is proved. All of you clear till now? Invariance is proved. All of you clear till now? The entire measurement model.
Yes, sir.
All of
Yes,
you clear
sir.
till now? So this is
Yes,
what
sir.
called as metric. This is what called as first part of metric invariance. First part of metric invariance. Now we will go to some other testing of metric invariance. We will go to some other part of metric invariance. We will go to some other part of metric invariance. Now look at here. Look at my AMOS graphics. Look at my AMOS graphics. Let us go to these values, and we will go to the measurement weights. What is the main theme I said? In the metric invariance, we will constrain the measurement values or factor structure or factor loading or regression weight of indicator on the factor. So there are some options in the left hand side: unconstrained, measurement weight, structural variance likewise. So click on measurement weights. Click on measurement weights. Look at here. Click on measurement weights. Click on measurement weights. Click on measurement weights. All of you are clicking. Such like values are coming. Such like values are coming. Look at here. A1_1 is equal to A1_2. A1_2_1 is equal to not A1. I'm sorry. A2_1 is equal to A2_2. Look at here. Look at these values. Look at these values. Look at these values. What it is written? Look at this value. A1_1 is equal to A1_2. What does it mean? The first indicator that is measuring the first factor for the male has been compelled to be equal for the female. First indicator measuring the first factor for the male is constrained to be or compelled by the researcher to be equal to the female. So A1_1 has been equalized with A1_2. A1_2. Now let us make it constant. Let us make a new let us take 2 or 3, any one structure. So from A5_1 to A5_2. So copy and create a new structure, so that let us put it as factor 1 constraint, factor 1 constraint, and paste here. So a new factor is created. Sorry, a new name is created that I have constrained the factor 1 only. I have constrained the factor 1 only. So close that. Then make another operation. Start estimating. Start estimating. Go to the output. Go to the output. Go to the model comparison. Now look at here. The factors that I have constrained, factor 1C is also insignificant, and it is highly insignificant. It is highly insignificant. That is 0.658, much more above the 0.05. But our prime date used to make a model note for the estimates. Model note, pairwise comparison, model fit. Model comparison. Yes, the same thing I was explaining. What it has written, look at here, assuming the model unconstrained to be correct. And this is also saying that if you go by one factor, compelling to be constrained, compelling to be equal for male and female, rest of the 4 factors also, rest of the 4 factors out of the 5, rest of the 4 factors also are not significantly differing over male and female. If I am constraining one factor, that 5 indicators measuring factor 1, I forcefully constrain that is equal for male and female. Rest of the 4 factors also, it is not making any significant difference over the male and female, because all the p values, look at here, all the p values are more than 0.05. All the p values are more than 0.05. All of you are clear till now? All of you are clear till now? All of you are clear till now?
Yes, sir.
Yes, sir. Yes, sir.
Okay. Let me go for any other testing. Let me go for any other testing. What is this chi-square for model note? This is for measurement weight, and this is for FC. Yes, these 2 things are coming: measurement weight and testing. Yes, 2 things are coming. Okay, so all of you have downloaded. The that start week Excel file. All of you have downloaded the start week Excel file. If not, again download.
Yes, sir.
All of you have downloaded?
Yes, sir.
Okay. If not, again download. Go to the start week. Google it. Go to the start week. Go to the start week. And start week gaskination. Start week gaskination. Start week gaskination. Internet is very slow. So those who have downloaded this like Excel sheet, they might be getting. This like Excel sheet that might be getting. Is that right? Is that right?
Yes, sir.
Or yes or no?
Yes, sir. Yes, sir.
See, look at here. Earlier we have done for the reliability and validity, there is a validity master. Another option is there, chi-square difference. Click there. Another option, there is a chi-square difference. Another option, there is a chi-square difference. Click there. Done it? Done it?
Yes, sir.
Are you getting this
Yes,
value
sir.
or not? Are you getting this option chi-square difference or not?
Yes, sir.
Okay.
Yes, sir. Yes, sir.
Okay.
Yes, sir.
So now now go to the output. Go to the output. Click in the unconstrained. Click in the unconstrained. Copy the chi-square value. Copy the chi-square value. And please remember the degree of freedom 398. Please remember the degree of freedom 398. So paste here. See, it is written unconstrained. So paste here. Paste here. And the degree of freedom is 398. 398. Right there. Now again go to the output. Go to the factor that I have constrained. Go to the factor that I have constrained. In the left hand side it is appearing. See, I have named it as factor underscore 1C. So click there. Once you click there, another chi-square is appearing. See, 649.028. Copy, and please remember the degree of freedom 403. Go to the Excel sheet. Paste here. See, it is written fully constrained. For the example, in order to save the time, I have constrained only one. It is taken full constraint. Still, in order to show you, I am showing you. So paste there. Paste there. And what was the degree of freedom? 403. Right here, 403. Right here 403. So what it is written, look at here. What it is written? Look at here, it is written invariant question mark. In the below it is written yes. That means we win in the race. There is no significant difference so far as measuring the factor 1 is concerned over male and female. We win in the invariance. That means the 5 indicators measuring factor 1 is invariably measuring for both male and female, is invariably measuring for both male and female. That means we win in the invariance testing. That means there is no significant difference. That means over the male and female, the 5 indicator that are measuring the factor 1 are not differing significantly. Had it been the invariance testing not justified, but here, look at here, where you are saying yes, it will be said no. Automatically, it will be show you no. If there will be a significant difference, here it will be written no. If it will be a significant difference over male and female, it will be written no. But we win in the invariance testing, hence it is written yes. All of you got this? All of you got this? Any doubt till now? Any doubt till now? Any doubt till now? Any doubt till now?
No, sir. No, sir.
No, sir. Thank you.
No, sir.
All of you practiced? All of you practiced or not? Or simply saying yes?
Yes,
no?
sir.
No, sir. That macro is not working. Working in my PC, sir. That's why I did not practice with that one.
No.
So I think I need to work. Yeah.
Bapan sir, for this particular operation, no need of macro. It will operate in any computer. Please practice.
Okay, sir.
That is the reason I am asking everybody. This particular operation, there are so many options. The macro option, deliberately I am not going. This particular operation of the Excel sheet, no need of macro enabling. It will operate anywhere. All of you, please, anybody who has not operated, please operate. I hope you are all confusing. This particular operation is not requiring macro. The same Excel sheet, download. So many other options are required where macro is required. But this particular operation is not require macro. Please download it and start operating. If you do not know, again I will say you. Please download from here. There is a Excel. Look at here. Go to the resource. There is a Excel start tool. Download that. Such like Excel sheet will appear. Go to the chi-square different option. There are so many options. First option was validity master. So many other. There is a two-way interaction. There is a group difference. There is this group difference require macro. That is the reason I am not going to here. This group difference require macro. That is the reason I am not going to here. See, another option of testing invariance is there is a chi-square difference written here. Please look at here. Click the option chi-square difference. Then go to this unconstrained and constrained chi-square value. I have operated just now. This is not requiring macro option. This is not having any problem. This is operating in any computer. Anybody who has not operated, please do it so that you will enjoy. Otherwise, you will fumble definitely. This is not requiring macro. Are you all following or not? I do not know.
Yes, sir. We got you, sir. Thank you.
So, for the sake of that, I am doing another thing. This is what I have done for the factor 1. Let me delete the factor 1. Then let me constrain the factor 2. Look at here, delete. If you double click on factor underscore 1C, that just I have created. Double click here, delete it. Delete it. So I will constrain the factor 2. What is that? A underscore A6 underscore A is equal to A6 underscore 2. So this is extending up to A10. Let me constrain the factor 2 also. Let us see what is happening. So copy here, click on new, and let us write here factor 2C, factor underscore 2C, constraint, C means constraint, paste here. Now I have compiled the indicators of factor 2 to be equal for both male and female. I repeat, I compiled the AMOS, the 5 indicators that are measuring factor 2 to be equal for both male and female. Now this operation is over. Now see, automatically another, look at my cursor movement, automatically another option is available for us, factor underscore 2C. Now start operation again, calculate the estimate again, calculate the estimate. I am doing again those who have not done. Calculate the estimate. Estimation is over. Go to the output screen, that is view text. Go to the view text, that is output screen. Go to the view text, that is output screen. As because my output screen is automatically open, I need to go there. And go to the what is called as notes model, notes per model. Go to the notes per model. Look at here, it is written chi-square value. Look at here, it is written chi-square value. It is for on constraint. Look at here, it is written on constraint. Look at here, it is written on constraint. Click in the bottom left, that is factor underscore 2C, just I have created. Click there. Look at here, it is constrained. It is constrained, not written, but it is factor underscore 2. So another chi-square value is appearing. Another chi-square value is appearing. Look at here, another chi-square value is appearing. So what you need to do, you need to go to the on constraint, copy the chi-square value here, copy the chi-square value here. Remember the degree of freedom 398. Go to the chi-square different option of the Excel sheet. Copy, you have already copied, paste here. Look at here, it is written on constraint, so paste here. So paste here. Then again go to the output screen, click factor underscore 2C. Look at here, another chi-square value is appearing because we have constraint. Copy this chi-square value and please remember this degree of freedom 403, then paste here. Now look at here, 403 earlier it written, no need to write again. Now look at here, automatically it is saying yes. Automatically it is saying yes. That means there is no difference over male and female so far as 5 indicators that are measuring the factor 2 is concerned. That means those 5 indicators are measuring factor 2 are not significantly differing over male and female. That means we win in the invariance. That means invariance is justified. Invariance is justified. Here it is written yes. Here it is written yes. All of you clear till now? All of you clear till now?
Yes, sir.
Yes, sir.
Okay. So these are all called as indirect testing, chi-square testing. Another macro testing is available. If you can do, go to this Excel, another option, group difference. Just I am showing you the operation, but it may not work for most of the people, to me also, because macro, I do not know, for some machines, macro is not, is creating difficulty. Go to the output file, go to the output file, go to the estimates, go to the estimates. These estimates, see, if you go to the estimates, automatically the male and female will be highlighted, will be activated. So these are all written for male. These are all written for male. And if you click in the female, these are all written for female. Okay, let me delete that factor underscore 2 because I will take the entire model for our convenience. Let me delete that factor underscore 2 so that entire theme will be available to me. Entire model measurement value will be available to me. I got the entire model measurement value. Please click on the estimate. If you click on the estimate, the male and female left hand side will be automatically activated. If you click on the male, so these are all unconstrained male values. These are all this particular table. If you click on female, this, look at here, it is written female unconstrained. So take the male values here from here. Take the male values from here, copy, and go to the Excel sheet. That is that macro Excel sheet. Go to a option, it is written group difference. Paste here. Paste here. Now what is the second group? That is constrained. Now go to the constrained values. Go to the constrained values or female values. Female. Click here. Copy here. Take here and paste here. Paste here. Done. Then another thing you need to paste, that is critical ratio. Look at here, another thing is there, that is critical ratio. Go to the output, click on the what is that? Click on the pairwise parameter comparison. Click on the pairwise parameter comparison. Pairwise parameter comparison. I think have I checked the critical ratio? No, sorry. I have not checked the critical ratio. Again, I need to operation because critical ratio is required. See, look at here what is written critical ratio. So I have not ticked the critical ratio. So again, I ticked the critical ratio. Look at the Excel file. It required the critical ratio. I didn't check. I didn't tick the critical ratio. Now I tick the critical ratio. Now I am operating again because I need the critical ratio value. Go there. Estimates, modification indices, minimization pairwise, then model comparison. Modification indices, minimization history, pairwise comparison. Yes, it is critical ratio. So what I need to do, I need to copy here. I need to copy here. I need to paste here. Paste here. Paste it. So after that, simply I need to click on the button. Let us see it is happening or not. No, there are some runtime error. Anyway, if anybody is operating, can say me whether it is appearing or not. Anybody is doing that? Anybody is doing that? Is it valuably appearing for them? Anybody is doing? Anybody is doing this operation? I think nobody is doing this operation. Anybody is doing this operation? Anybody is doing this operation? Lakshmikant, are you doing? No. Lakshmikant.
Yes,
sir, are you doing?
Facing the same problem, sir.
Okay. Sumande, are you doing? Sumande, are you doing?
Sir, nahi ho raha hai. No, sir, it's not. Runtime error is coming.
Some macro enabling is problem. Okay, anybody is operating? Anybody? There is Lakshmi Prabha Mishra. Are you doing this? No. Are you doing this? No. Okay, I think nobody else is operating this. So this is what the indirect method of testing. So again, I'm repeating. First, we have compare. First, we have without constraining compare. We have seen whether the model fitting indices are very much similar and fitting absolutely or not. Then we have compared the regression weight. Are they differing or not? Even if it is little bit differing, if it is similar, then we can say initial inference we can draw that male and female are not significantly differing. Then the third, we have gone to the comparison of chi-square. How we will compare the chi-square? By making a constraint. We have constrained some value by creating another factor. Then we compare the chi-square. And by comparing the chi-square, if the chi-square is significantly above 0.05, we will say key invariance is there. If it is less than 0.05, invariance is not there. Then we will go to comparing the chi-square on the Excel process macro, Excel macro. So simply you take the chi-square value of unconstrained and take the chi-square value of constraint, put there along with the degree of freedom. It will show you whether invariance is there or not by writing yes or no. And this is what the today's summary. Over to you, all of you, if you have any doubt. If you have any doubt, let me go for, I think this model is not there with you. Still, I will go to the structural model. Let me go to the structural model. See, look at the structural model of my research work. This is along with one of my scholars' research work. This is what the structural model. The same thing you can do for the structural model also. You can operate. So thereby you will get this particular path value. You are constraining this path and comparing all other three paths. You will constrain this path and compare all other path. You will constrain this path and compare all other path. Likewise, the entire structural model you can compare and see. So this is what called as first. So first we have gone for configural invariance. Then we have gone for matrix invariance. Then there is a invariance testing called as scalar invariance. So even more strict invariance is this error invariance. So first it is configural invariance, then it is matrix invariance, then you constrained both the weightage and regression values, residuals. Then it is called as scalar invariance. If you constrain the error terms also, it is called as error invariance. So configural invariance, you are testing by factor structure. Then matrix invariance, you are testing by constraining the regression weightage. Then you are going to the scalar invariance, you are testing by constraining both the factor weightage and the what is that called as a value, that is intercept value. The moment you will constrain both the factor weightage and the intercept value and compare, that is called as scalar invariance. And more strict is residual invariance or error invariance. You are constraining the error term and comparing. So this is what the conclusion for today. This is what the conclusion for today. If anybody is having any doubt till for the multi-group analysis, they can ask me. Over to you all. Over to you all. Anybody is having any doubt? Anybody is having any doubt? I think most of you are dormant or not listening at all. If no doubt, tell me.
We understand, sir.
Okay. Bapan sir, you are asking for imputation and path model.
Yes, sir. Yes, sir.
So it is a very long process. Time is not there, but still I am showing you. Look at here. There is a option in the analysis, data imputation. Look at here.
Yes,
there is
an
option in the analysis, data imputation. What does it mean? What does it mean? A single column will be created in another SPSS sheet for the BSI. Another single column will be created for POSC. Another single column will be created for COR. Another single column will be created for ACRB. So now,
Okay.
you got original value. Here you are not getting original value. It is a latent variable. So if you impute the data, what will happen? You will get original value for EBSC. Are you looking at my screen? My screen is visible to you?
Yes, sir. Yes, sir. Yes, sir.
A single column separate SPSS sheet will be automatically created for EBSC. On the same Excel sheet, if you are doing simultaneously, another column of data will be created for POSC. Now, how many column of data you are having for EBSC? 22 column of data. Now, Bapan sir, are you getting my point?
Yes, sir.
Now there are 22 columns of data. Once you impute, a single column of data will be created separately in a separate SPSS sheet for the EBSC. Another single column will be created for POSC. Another single column will be created for COR. Another single column will be created for ACRB. So now, no need to make any oval shape. Once you are getting original value, you will go for this particular shape. So look at here. You do need to do here ACRB. You need to do another here POSC. You need to do another here for ACRB. You need to do another here for
yes, sir.
Here you need to do another EBSC. Here it is POSC. Here it is ACRB, and here it is COR. So then what you need to do? From the EBSC, you need to draw a line here, then here, then here, then from here. Now this model is called as path model. And in the path model, only original values are there, no latent variable. So what will happen? By clicking here, you will go to the new SPSS datasheet that has been automatically created. So the same procedure, give the data, operate. Matter over? Clear? Bapan sir, clear?
Yes, sir.
Clear?
Yes, sir.
Okay.
Yes, sir.
So I hope last date, participants must be very much worried to conclude. I do not know how much worthy I could deliver to them, but this much I had to deliver to you. Unfortunately, one of the operations for this particular macro Excel sheet has not been performed. So if you perform that, you can get it. So over to you, organizer. If any doubt you have, you can ask. Otherwise, over to organizer. The last dates so that most of the participants might be in a hurry. Very less participants are there. Anyway, over to the organizer if anybody do not have any doubt. Over to the organizer.
Sir, my voice is audible.
Yes, sir. Yes, sir.
If there is no question, I think there is no question from our participants. So we will conclude here, sir. Okay. Thank you very much, sir. On behalf of ASBM University and participants, I convey my gratitude for being with us for a long 6-day session, sir. And looking forward to listen to you again in future programs, sir. Thank you very much, sir.
Thanks a lot.
For this informative and learning session. Thank you very much, sir.
Thanks a lot.
Thank you all the
participants. Thank you very much, sir.
If any participant have any doubt, they can reach me in the email also. No problem.
I'll share the details of yours, sir. I'll share.
Acha, Lakshmi Prabha Mishra is raising the hand. Is there anything to ask, or it is by chance?
Sir, today's PPT do we get, sir?
Definitely.
Yes, I'll share it.
Okay.
Definitely.
Okay, sir.
So thank you all. Thanks a lot again. It is a mutual learning.
Thank you very much, sir.
Thank
you very much, sir.
Thank you, sir. Thank you so much.
Thank you, sir. It was very informative session, sir. Thank you so much.
Yeah. Thank you all the participants.